this is Mr. Manley. This is a video on graphing log functions. And if you have seen my work on graphing functions before, you know that I always begin with a table of values, and I always start that table of values with the y-intercept when x equals 0 and the x-intercept when y equals 0. Here, when x is equal to 0, we're going to have log 2 minus 1. And that is the exact y-intercept, which we do want to know, but for graphing purposes, we may want to look at the decimal approximation of this. And just using a calculator, the decimal approximation is approximately -0.7. For the x-intercept, we've got the f of x equal to 0, which is going to be log x plus 2 minus 1 equals 0. And we want to isolate the log as much as possible. And then I'm going to use the definition of a logarithm here. Of course, we've got an understood base of 10 to the logarithm. So that will be 10 to the first is equal to x plus 2 using the definition of a logarithm. Therefore, x is equal to 8. And that is giving us our x-intercept. So on my scale here, maybe I want to do my x scale at 2 and keep my y scale at 1. We can have a different x and y scale. And then graphing the y-intercept at -0.7 is going to be there. And graphing the x-intercept at 8 is going to be there. And then, all right, so two things about the graph of a logarithm is, one, it is going to have a vertical asymptote. So if you remember and this is not the vertical asymptote that I'm showing. This vertical asymptote is not for this graph. I'm just talking in general about vertical asymptotes. And then all we need in order to finish the graph are 2 points. So if you saw my video on the graphing of an exponential function, we need 2 points and a horizontal asymptote to graph an exponential function. For a log function, which is the inverse of a exponential function, we need 2 points and a vertical asymptote. So if I had these 2 points and this vertical asymptote, I would have that shape there. Now, another thing about the vertical asymptote is that unless there is a horizontal shift, then the vertical asymptote is at x equals 0. And here we see that there is a horizontal shift, 2 to the left, if you remember your translations and transformations. So I'm going to put a vertical asymptote at x equals -2, which on my scale is here. And then I've got these 2 points already, right? I've got a point here, I've got a point here, I've got a vertical asymptote. So we have the graph of the function here, and then extending up to the right. And that's our log function. So it's kind of pretty tight in there with a lot of lines. I don't know if highlighting it would help. I don't think that really helps, but anyway, you can see where it is there. Okay, so that's the graph of a log function. And then let's just look at one more thing about this. Here I have, first of all, I have natural log, right? And also I did the vertical asymptote shifting to the right. So think about what that does to the x and y intercept. And we'll go ahead and take a look at it here. When x is 0, that is ln of -1. So you understand what that means. That is not real. It is non-real. And in this context, we're going to say it's undefined. So we were here looking for the y-intercept, and we aren't getting 1. We're getting an undefined value. Why is that? Because the vertical asymptote shifted to the right, which moves us away from the y-axis. And then doing this value here, f of x equals 0. So we're finding the y-intercept, and that'll be ln x minus 1 equals 0. And then e to the 0, right? E to the 0 equals x minus 1. So I'm getting, looks like I'm getting x equals 2 for that intercept. All right, so let's just graph what we have so far. We've got I'm going to do an x scale. I think I can just go 1 and 1 on the x scale and y scale. And because of this horizontal shift 1 to the right, which we mentioned there earlier for the x minus 1, that's going to shift us 1 to the right. That'll be a vertical asymptote here. And then we've got the x-intercept at 2. And then I just need one more point. Now, what would be a convenient value of x to put in? Perhaps if I put in, oh, I already have 2. So what would be a convenient value of x to put in? Not 1, 2. So I don't know. We're just going to have to put in a value that's not incredibly convenient, but just the next value in line, I would say, is x equals 3. We really just need to know if this is positive or negative, if you can think about why that is. So I'm going to go x equals, well, let's just do it as f of 3 is equal to ln of 3 minus 1, which is ln of 2. So what is ln 2? We could go to the calculator and key that in. But we can also think about this is a base e, right? So, and e is approximately 2.718. So what's in order to evaluate ln2, we're asking 2.718 to what power is equal to 2. So that's going to be 2.718 to the first power would be 2.718. 2.78, so it's got to be less than 1, but more than 0. So we're in between 1 and 0 here. We could just give a really rough approximation of 0.5. Maybe it might be nice to go ahead and show the interval that it is between 0 and 1 with the interval notation, but that might be confusing unless we indicated that in some way. But I'll do it here. So interval for, between 0 and 1. All right, so when x is 3, I've got a point here between 0 and 1. And then that's all I need. I've got 2 points in the asymptote, so I'll draw a curve through those 2 points, approach the asymptote, and then have the curve extending off up here to the right. So that is graphing a log function, and you see it's a pretty straightforward three or four step process, depending on if we need to find an additional point.